Hey everyone, in this video we are going to discuss the concept of subset, which is a concept of set theory. So here I have this definition of what does it mean to be a subset of another set. I have not used the wordy definition of the subset. Instead, to save my space, I used the symbolic way to define what does it mean for a set to be a subset of another set. So first of all, this is the symbol that says us that A is the subset of B. This symbol is also new to you, and this symbol is read as if and only if. This symbol means that this thing implies this thing, and this thing, this whole thing implies this very thing. So here is another symbol which we read as for all, for each, and this has a special name and is known as universal quantifier. So let us see what does this definition tell us. Now, if I have two sets A and B, I will say that A is subset of B if X belongs to B for all X belongs to A. Now, in simple words, this definition tells me that A, which is a set, will be subset of the set B if it satisfies this condition. And the condition is that whatever element belongs to the set A must also belong to the set B. In other words, for all the elements which belong to the set A, they must also belong to the set B. Only then we will say that A is the subset of B. So I have a question. When is a set A not a subset of set B? Now, in order to answer this question, you have to negate this very condition. This condition says me that A will be subset of B if every element of A is present in the set B. Means that if I can find even a single element in A such that that element does not belong to the set B, I will say that A will not be a subset of B. So I have here, this actually is the negation of this very statement, and it says us that A is not a subset of, this symbol is read as subset of, and this symbol is read as A is not subset of B. Now, when is a set not a subset of B? A is not a subset of B if you can find, if there exists, this symbol is also new to you, and it simply means that there is or there exists. A is not a subset of B if there exists at least one element in A such that that element does not belong to the set B. If this thing happens, that then I will say that A is not a subset of B. On the other hand, if every element of this set A is also present in the set B, in that case, I will say that A is the subset of B. Let us see some examples so that we'll be able to grasp the meat of this definition in a better way. Here is my first example, and in my first example, I have two sets M and G. M consists of, or in other words, M is the set of all books of mathematics, and G set consists of all the geometry books. I want to know whether G is subset of M or not. Simply, I will apply the definition of being subset to this very example. Now, as you can see, geometry is the branch of mathematics. You know it. It means that every geometry book is itself a mathematics book. Means that our set M will consist of all the mathematics books, including geometric books as well. Means that every element, every book in this set G is going to land in the set M. Now, by definition, means that G is going to be the subset of M. Why it is the subset of M? Because every geometry book in itself is a mathematics book. Now, okay, I have second example, and in my second example, I have two sets R and S. My set first R consists of all the rectangles in some given plane, and my second set S consists of all the squares. Now, you know from elementary geometry that every square is a rectangle, but every rectangle is not a square. Now, if every square is a rectangle, means that this set is going to consist or is going to include all the squares as well besides other rectangles. So by definition, S is the subset of R. Why? Because simply every square is a rectangle. Now I have a third example. In the third example, my set consists of set A. It has these elements. As you can see, these are displayed. And set B consists of these two elements. And B is clearly the subset of A. Why? Because by definition, B will be subset of A if every element of B will be present in the set A as well. So let us see whether the every element of B is present in the set A or not. Obviously, B consists of just two elements, that is 99 and pi. And obviously, these two elements are also present in this very set. So by definition, B is going to be the subset of A. So I have third example, one more example here, and I have two sets A and B, and this is the roster form of these two sets, and I want to know whether A is the subset of B or not. Now, when I apply the definition to this very example, I find that A is not the subset of B. Why A is not the subset of B? We know A will not be a subset of B if you can find at least one element in A which will not be present in the set B. So A is not subset of B means that there must be at least one element in A which is not present in the set B. So let's see. Now, obviously 20 is here, 22 is here, 29 is here, but 37 is not here in this set B. So according to this rule, according to this implication, A is not the subset of B. Why A is not the subset of B? Because simply I have found one element in the set A which is 37, and that 37 does not belong to the set B. Now similarly I have example E. Now this is very interesting. I have set A, and it consists of these elements 1, 3, 5 and 0, and my set B consists of these two elements. As you can see, these two sets are actually equal sets because they have got equal elements or same elements. So I want to know whether A is subset of B. I have deliberately used a different notation here. I could have used A here as well, but that does not matter here. So I want to know whether A is subset of B or not. In order to check whether A is subset of B, I just have to check every element of A must be an element of B as well. Obviously, every element of A is also present in B, means that A is going to be the subset of B. And in this case, these two sets are equal. Now, I have a question. Can you generalize from this very particular example that every set is a subset of itself? This is a question for you. And inshallah, in the next video or some other video, I will discuss this very thing, that every set in fact is a subset of itself. One more thing is here. When diagrammatically, let us suppose that this is my rectangular, this rectangle represents the universal set, set A is represented by this bigger circle and set B is represented by this inner circle, smaller circle. Now, obviously, if A is subset of B, if B is subset of A, means that every element of B is going to be an element of A as well. That is why I have included Venn diagrammatically circle B inside the circle A, because B is subset of A. When diagrammatically A is subset of B, we display it this way. Thanks a lot.